Welcome to lecture number 3 on the course of electrical circuits and network analysis. In this lecture, I will discuss about the DC network theorem. Okay, so this is lecture number 3. So at first, before going to the DC network theorem, consider a simple circuit using KCL and KVL solutions. Okay, so at first, if I draw a simple circuit like that, so there are two voltage sources. So this is the entire circuit. Suppose this is 10 volt, this is 5 volt, and the resistances are 5 ohm, 10 ohm and 2 ohm. Now if I have to find the current through this 2 ohm resistance, suppose this current is your IL, that is the 2 ohm resistance is considered here load resistance RL, and through which the current will be required to find out, that is the IL. So this current is I1 from the 10 volt source and this current is I2 from the 5 volt source. Okay, so if we apply KCL and KVL in this circuit, then what we can write? So look, there are two mesh. Okay, one is this and that is this. That means in this node actually the two current I1 and I2 will be added up and will be flow as IL through the 2 ohm resistance. Okay, so first the KVL equation will be 10 minus 5I1 minus 2IL equal to 0. This is the first KVL equation considering the 10 volt source, and second KVL equation considering the 5 volt source will be 5 minus 10I2 minus 2IL equal to 0. This is number 1, this is number 2. And across this node, if we apply KCL, then the third equation will be IL equal to I1 plus I2. Okay, so there are 3 unknowns and 3 equations, so easily it can be solved. So if I substitute the value of IL from the equation number 3 and put is in equation number 1 and equation number 2 in place of IL, then number 1 and number 2 equation will be rewritten as 7I1 plus 2I2 equal to 10 and 2I1 plus 12I2 is equal to 5. This is number 4 and this is number 5. Now then the 1 and 2 equation can be modified and it can be written in terms of I1 and I2. Replace the value of IL from the equation number 3. Okay, so now there are 2 unknowns and 2 equations, so easily it can be solved, and by solving we can write, by solving we can write easily I1 will be 11 by 8 ampere and I2 will be 3 by 16 ampere. Okay, then what will be your IL? Then your IL will be summation of I1 plus I2, that is 11 by 8 plus 3 by 16, that is equal to 25 by 16 ampere. So this is your IL. So using KCL and KVL we can solve the circuit. Okay, but in place of KCL and KVL, if we apply the DC network theorem, then what will happen? Look, there are several DC network theorem are present, that is superposition theorem, Norton's theorem, Thevenin's theorem, maximum power transfer theorem, etc. So basically the complexity of the solution, that means the several number of KCL and KVL equation can be avoided. So the complexity can be reduced with the help of DC network theory. So first, if I tell about superposition theorem, so what is this? Superposition theorem. Basically, this is a one type of DC network theorem. So what is it? Superposition theorem in a circuit can be applicable when the circuit contains minimum two sources or more than two sources are allowable. The sources may be voltage source or maybe current source. Okay. So considering a simple circuit having two number of voltage sources, suppose if I draw a circuit like that containing two number of voltage sources, suppose this is voltage V1, this is voltage V2 and R1, R2 and R3. Now we have to find the current IL through this resistance R3 using superposition theorem. So what will be your solution? So there are some steps for solving a problem using superposition theory. So what is the step 1? The step 1 will be considering a single voltage source acting alone at a time and remaining the voltage source is replaced by its internal resistance. Okay. As I am considering here all the sources are ideal, so in case of ideal voltage source the internal resistance will be 0, that means it will be replaced by the short circuit. If there is a current source, also the internal resistance is 0, so the current source is replaced by the open circuit. So first step 1 is considering V1 only. Then what will be the circuit? The circuit will be V1 present and all the resistance are remain as same. So this is V1, this is R1, R3 and R2. So as the V1 source is present, so the current from the V1 source is noted as I1 supply current. Okay, and from this node actually the current will get divided. One current is flowing through this R2 resistance and another current is flowing through this R3 resistance. Then we have to find out the current flowing through the R3 resistance. Suppose as I am considering the voltage source V1, so the current flowing through R3 resistance is now assumed as IL1. Then what will be your source current? First of all, your source current will be I1, it will be supply voltage V1 by R equivalent. Then what will be your R equivalent? Here R2 and R3 are connected in parallel through a short circuit branch with this R1 series. Then R1 plus R2 parallel to R3. And what will be your IL1? Simply current dividing rule is applied here to find the current IL1 because the current will get divided in between R2 and R3. So your IL1 will be the supply current into opposite branch resistance R2 divided by total resistance R2 plus R3. So this will be your expression for IL1. Next, step 2. Step 2 means considering V2 only. Then what will be your circuit? If I redraw the circuit, then your V1 source is now replaced by the short circuit, and here V2 is only present. So this is V2. So and this is R2, R1, R3. So now I am considering the supply voltage V2, that means the source current from the V2 is I2, and here again across this node the current will get divided. One is flowing through R1, another one is flowing through R3, and we have to find the current flowing through the R3, so that is assumed as IL2. Okay, so now again what will be your source current? What will be your source current? I2, that is V2, supply voltage V2 by R equivalent. So now what is R equivalent here? Here the R1 and R3 are connected in parallel through a short circuit branch, and with this R2 is series, that means R2 plus R1 parallel to R3. Okay, so this will be your expression for the main current I2. And then what will be your IL2? Again current dividing rule is applied here. So your IL2 will be the main current I2 into opposite branch resistance, that means R1 divided by total resistance R1 plus R3, through which the current will get divided, I2 into R1 by R1 plus R3. And next the final step will be when the two supply voltage V1 and V2 both present. Step 1 will be considering V1, step 2 is the considering V2 supply voltage only, and step 3 is V1 and V2 both considered. Then your IL will be the summation of IL1 plus IL2, because when the two supply voltage is considered, then IL1 is the current flowing through the resistance R3 considering the V1 supply voltage only, and IL2 is the current flowing through the R3 considering the V2 supply voltage only, and total IL will be the considering both supply V1 and V2 both, then your current will be IL equal to IL1 plus IL2. So this is the final expression for the current flowing through the R3 resistance using superposition theorem. Okay, so now if I consider the same problem which I have already used for KCL and KVL, that same problem, if I draw the circuit, this is 10 volt, this is the another voltage source. Okay, so this is 10 volt, 5 volt, 5 ohm, 10 ohm and 2 ohm, and your current direction will be like that, plus minus, this is plus minus, and across 10 ohm resistance this side is plus, this side is minus. Okay, so this is your current direction. Next, what is your step 1 for superposition theorem? Step 1 will be considering the 10 volt supply only, that means considering only 10 volt. Then redraw the circuit, only 10 volt is present, that is like that. So this is 10 volt and this is 5 ohm, this is 2 ohm and this is 10 ohm. Now we have to find the current through this 2 ohm resistance. Suppose this is IL1. So at first we have to find the source current I1. Then what will be your solution? Your I1 will be supply voltage 10 by R equivalent, that means 5 plus 10 parallel to 2, because here 10 ohm and 2 ohm are connected in parallel through a short circuit path with this 5 ohm series. So your I1 will be, after calculation, 3 by 2 ampere. Okay. Next, we have to find out IL1. So what will be IL1? Simply the main current, that means I1, into the opposite branch resistance. That means we have to find the current IL1. Its opposite branch means 10 ohm in, by the total resistance. That means 10 plus 2, 12 ohm. So your IL1 will be, after calculation, 5 by 4 ampere. This is your IL1. Okay. Next, step 2. Step 2 is considering 5 volt only. Then 10 volt supply is replaced by the short circuit here. That means this is the diagram. Five volt, 10 ohm, 5 ohm, 2 ohm. Then at first the same thing. First I am going to calculate I2 and then IL2. Then what will be your I2? Your I2 will be very simple. Supply voltage 5 by R equivalent. Here 5 ohm and 2 ohm. These two resistors are connected in parallel with this 10 ohm series. That means 10 plus 5 parallel to 2. So after calculation it will be 7 by 16 ampere. And next we have to find IL2. So IL2 will be the main current, that means 7 by 16 into opposite branch resistance. So the opposite branch of the IL2 will be 5 ohm and divided by total resistance, that is 5 plus 2. So after calculation it will be 5 by 16 ampere. Okay. So the final step, IL3, sorry, total IL, the step 3. Step 3 is when 10 volt and 5 volt both are present. 10 volt and 5 volt both considered. Then what will be your IL? That is the summation of IL1 plus IL2. Then your IL1 is 5 by 4 and IL2 is 5 by 16. So after calculation we get again 25 by 16 ampere. That means that results are same. Okay. Using KCL KVL we have got 25 by 16, and using superposition theorem also we have got 25 by 16 ampere. Okay. So this is the all about superposition theorem. So next, Norton's theorem. Okay. If I consider a simple circuit like that, so Norton's theorem is applicable in a circuit when it contains one or more sources. Suppose this is V, this is R1, R2, R3, and this is a load resistance RL. Okay, considering the circuit with a single voltage source, then we have to find the current IL through this RL resistance or load resistance. Okay, so the step for solving Norton's theorem, first step 1. Step 1 will be the load resistance will be replaced by the short circuit, and hence to find the short circuit current or Norton's equivalent current IA. So first, if I redraw the circuit, then it will be like that. So this is V, this is R1, R2, R3, and this through this short circuit path the current is flowing, that is ISC or I Norton. This is your short circuit current. So first you have to find the total current, that is I. So what will be your I? Total current will be V by R equivalent, that means V by R2 and R3 connected in parallel to the short circuit path with this R1 series. So this will be your I, and your ISC or IN will be the main current I into opposite branch resistance R2 divided by R2 plus R3, because from this point the current will get divided. One is through R2 and another is through R3. Now we have to find the current through R3. So your current dividing rule is applied here, and ISC will be this. Okay, this is your step 1. Next, step 2. Step 2 is to find Norton's equivalent resistance. So to proceed the step 2, first what we'll do, the source will be replaced by its internal resistance at first. So here is a voltage source, so it can be replaced by the short circuit. Okay, and the load resistance will be replaced by the open circuit in the step 2, and we have to calculate the Norton's equivalent resistance from this open circuited terminal. Okay, R1, R3 and R2. So how it can be calculated? Consider a fictitious voltage source in place of Rn. Simply consider a fictitious voltage source in place of Rn. That means this, from this terminal current will be flowing, and across this node the current will get divided through R1 and through R2. Okay, that means what will be your Rn? Your Rn will be R1 and R2 are connected in parallel because the current will get divided through these two branches with this R3 series. So R3 plus R1 parallel to R2. So this is your Norton's equivalent resistance, right? Step 3. Step 3 is to find IL. Okay, so here first we have to draw the Norton's equivalent circuit. That is, we have already got the current, that is ISC or I Norton, with this one resistance is connected in parallel, that is your Rn, and with this another resistance is connected in parallel, that is your RL. Now the current will get divided again through Rn and RL. Now you have to find the current through RL, that is your IL. So what will be your IL? Your IL will be the main current ISC into opposite branch resistance Rn divided by Rn plus RL. So this is your step 3, and to find the current flowing through the load resistance using Norton's theorem. Okay, so again if I consider the same problem, then what will happen? The problem is same, that is, this is 10 volt and the same problem, that is 5 volt, this is 10 volt, and this is 5 ohm, 2 ohm and 10 ohm. So using Norton's theorem, we have to find the current through this 2 ohm resistance. So step 1 will be the load resistance is replaced by short circuit. So if I redraw the circuit, so it will be like that. Okay. Then you have to find the short circuit current, that is ISC. So now 10, 5, 10 ohm, 5 ohm. So look, there are two current basically. From the 10 volt source, this current is I1. From the 5 volt source, this current is I2. And from this node, again I1 and I2 will be added to form the ISC or I Norton and flowing through the short circuited terminal. So your ISC will be summation of I1 plus summation of I2. That means I1 means simply V by R, 10 by 5 and 5 by 10, and it will be your 5 by 2 ampere. So this is your ISC or I Norton from the step 1. Clear? Step 2. What is the step 2? Step 2 is the source voltage is replaced by the short circuit. Again, and the load terminal is open. Okay. This is your step 2. This is 5 ohm. This is 10 ohm. So again, calculate the Rn from this terminal. So look, again, if we assume a fictitious voltage source in place of Rn, that means the current will start flowing through this terminal and across this node it will divide to the 5 ohm resistance in left side and to the 10 ohm resistance in the right side. That means with respect to this fictitious voltage source, the 5 ohm and 10 ohm are connected in parallel. Okay, then your Rn will be 5 parallel to 10. So that is 10 by 3 ohm. Okay, next you have to calculate step 3, that is IL. So IL, so to calculate the IL, first we have to draw the Norton's equivalent circuit. Okay. Then what is ISC or IN? That is 5 by 2 ampere. Rn is 10 by 3 ohm. RL 2 ohm. So the current will get divided from this point. One is across 2 ohm and other is across 10 by 3 ohm. Next you have to find the current through the 2 ohm resistance. Then your IL will be main current 5 by 2 into opposite branch resistance, that means 10 by 3 into 1 by the total resistance. So after solving you will get the same answer, 25 by 16 ampere. That means the interesting thing is that irrespective of any network theorem and any KCL KVL equation, if the problem is same, if the required or measured quantity is same, the answer will also same. Okay. IL is 25 by 16 ampere for each cases using KCL KVL or using superposition theorem or using Norton's theorem, that will be same. So this is the final conclusion. So now if I check the circuit in practical, because we have calculated all the calculations in theoretically, now if I check the circuit in simulation in MATLAB Simulink environment, then what will be the result? Now let's see. So look, this is the same circuit which I have already solved in theoretically, and it is the MATLAB Simulink environment. So if I run the simulation, I will get the value of current flowing through the 2 ohm resistance. Okay. So if I run the simulation, Now the value, that is 1.563 ampere. Okay, so look, your IL will 25 by 16 ampere. I have already got. So further, if we simplify this, your IL, so you can check it using your calculator. It will be near about to 1.563 ampere. So that means your theoretical calculation and your practical result is now validated. Okay, that means your solution was right and your results was right. So this is the conclusion of today's lecture, and this is all about superposition theorem and Norton's theorem. With this I am ending.